Welcome back to Learning Integration. This is the basics of integration, learning integration by substitution. So the main things that you should learn when you're doing substitution is that you only use substitution if what you're integrating, or what you're finding the integral of, is a function times a function. If one of the functions is one of the functions a function within a function, and I'll show you that. And is the function a multiple of the derivative of the inner function? Now that might be a bit of a mouthful, but I'll show you with an example, 2 examples, because it takes a bit time, why that is. So let's start with an example. So we have a function x bracket x squared plus 1 to the power of 2. Okay, it's a function times a function. Is one of these functions within a function? Yes. And is the function a multiple of the derivative of the inner function? Well, that, if we were to derive this, it looks similar to that outside, which is basically what it's asking. Does that look similar to the derivative of the inside? And yes. And if you can't see that, I'll show you right now why. So, for now, I'll write out the function, or the integral. We use a capital F, and we use the fancy looking F or S, however you want to put it. Insert the function. Put dx on the end. Now, this is what you do with substitution. Generally you write sub, or I write sub because it's shorter than writing the whole word substitution. You sub in a letter, which I'm using u, for the inner function. So I'm subbing u in for x squared plus 1. Now I'll grab a separate sheet and show you what that'll look like. That means that our function will look like x multiplied by u to the power of 2 dx. So I'm just subbing in u for this. Now, when I mentioned before, if this looks similar to the derivative of this, that's because we're going to find the derivative of the inside function. So derivative of u, the variable is x, so the derivative of u with respect to x is going to be 2x, because the derivative of x squared is 2x and the derivative of 1 is 0. You see how we've got a dx here, and we've also got a dx over here. That isn't by coincidence. We can actually rearrange this, because this is a fraction, du over dx. We can rearrange it so we divide this by 2x, and we'll bring the dx up top and multiply it. So we're essentially going to switch these around and end up with du over 2x equals dx. See what I've done? I've multiplied the dx up and I've divided the 2x down. Now we've got the dx on its own. Here we've got the dx on its own. We're saying that du over 2x is equal to dx. So we're going to sub that in. Hence the name substitution. So we'll rewrite this. X bracket u 2 du over 2x. Now, because this is essentially x multiplied by u squared multiplied by derivative of u multiplied by du divided by 2x, we can just, this divided by 2x can float around on any one of these because it's all multiplied together. So I'm going to cancel out the x, and I'm going to bring this fraction, du over d2, I'm going to split that and make it 1 over 2 u squared du. Because multiplying 1 over half by du, you would get du over 2. So I've just pulled it away. Now, like I explained in a previous episode, multiplication by a constant rule means that you bring the constant out. You integrate without the constant. See how that worked? Just brought it out. It's still multiplied, but once I find the integral of this, then I'll multiply the half back in. But until then, I'm just going to find the integral, or the antiderivative, of u squared. Okay. Now it's easy, because all we've got to do is the power rule. So we've got 1/2. And now, the power rule. When finding the antiderivative or integral, you add 1 to the power. So that's what we'll do. U, add 1 to 2, you get 3. And then you divide by the new power. The new power is 3, so we'll divide by 3. And then we'll plus c. Now what I'm going to do is multiply the half back in. And what I end up with is 1 over 2 multiplied by u to the power of 3 over 3 is u to the power of 3 over 6. Because 2 times 3 is 6. And what I'm going to do here is write plus, and I'm going to use a different letter, h. Now why am I using that? Because h, I'm going to write that h is equal to 1/2 multiplied by c. Because what we're doing is we're expanding the brackets. We're multiplying 1/2 by that and getting that, and we're multiplying 1/2 by that and getting that. Now you don't have to do this. Most of the time you don't have to do this, but in uni I got told I had to do this, or told that it was preferred, and they did the whole wink wink nudge nudge, because it's correct. If you put a c down here, it's in a way incorrect, because you don't know what this is. It's just showing it's a constant. You don't know what it is. But h, you still don't know what it is, but you know for sure that it's half of whatever this was. That's what I've got here. It's like if I gave you a handful of something and you didn't know what it was, and I took half of it away, you still wouldn't know what it was, but you've got half of it. Half of what I originally gave you. That's essentially what this is. So I'm only showing you this because this is the correct way. Usually you can write C and get away with it, but that's probably not a good habit to get into. But anyway, that is, and I'll substitute u back in. U, we said, was x squared plus 1. Add that to the power of 3 over 6 plus h. Put the capital Fx out the front, and you have your antiderivative, or your integral. Now, I'll do one more example, because that was a bit of a mouthful. Okay. So we have example 2. Let's say this one, function. It equals x squared plus 1, bracket, multiplied by x to the power of 3 on 3 plus x to the power of 5. Now, I wrote this a certain way but you can see here that if you can't see it, that's fine. You'll learn how to see these things the more you do them, the more you practice, obviously. But this, if you were to derive it, it looks similar to this. And so, because it's a function times another function, and you can the inner function looks like, if you derive the inner function, it looks like that. You use substitution generally. So, we'll write this out. Capital F, fancy looking S, x squared plus 1, another bracket, x to the power of 3 over 3 plus x, bracket to the power of 5, dx. Just like before, because I said that this, if you were to derive it, it looks similar to this, I'm going to make this u. So I'm going to sub u in for x to the power of 3 on 3 plus x. So that means this function will look like x squared plus 1 u to the power of 5 dx. Anyway, I'll make that look a bit more like a u instead of a h. Now we're going to solve this, just like before. Du respect to x, find the derivative of this. We'll bring the 3 down. 3x, take 1 off the power to the power of 2, divided by 3, plus derivative of x is just 1. If we cancel out the 3's, because we have a 3 multiplied and a 3 divided by, or a divided by a 3, we cancel them out. And so we have x squared plus 1. Now, if we were to bring the x squared plus 1 onto the bottom and bring the dx up to the other side, it would look something like this. Du over x squared plus 1 equals dx. We start to notice something, and that something is that x squared plus 1 is the same as x squared plus 1. And because we have a dx here and a dx here, we can sub in all this for the dx. And what we'll get is x squared plus 1 u to the power of 5, and multiplied by, no longer multiplied by dx, but multiplied by du over x squared plus 1. Now because we have an x squared plus 1 divided by an x squared plus 1, we can cancel them out. And all we're left with is the integral of u to the power of 5 du. Okay, we know that when we're doing this, this is the power rule. We're going to use the power rule to solve it. So we have u, we add 1 to the power, 5 plus 1, 6, divided by the new power, divided by 6, plus c. Now I'm going to finish this off by writing the capital equals, sub in u, we said u was x to the power of 3 over 3 plus x, and that's what we're going to write here. X to the power of 3 over 3 plus x to the power of 6 on 6 plus c. Going that into the camera. Plus c. That should be brought down in line with this, but that's generally the gist of it. Now, the reason I've got a plus c here, and not like what I did before where I had a plus h, that's because we're not multiplying it onto anything. The c is just a c. If I was multiplying something onto it, I would change the letter because I'd show that it's changed, but it hasn't changed. The c is still the same c. Nothing's changed. Now, that there is the derivative, not the derivative, the integral, or the anti-derivative of this function up here. Now I hope this video helped, and I also hope you have a good day. Thanks for watching.